You're listening to the Dr. Shoup Show. We do dental differently. Must not miss information is online at ddsradio.com.
Well, I'm glad you're here with me. I really appreciate it. And this subject is really one that is, in many ways, to the medical community, to the scientific community, a mystery. And that whole mystery revolves around the issue of pain. You and I have talked about pain before, how pain is incredibly subjective in that what is painful for you may not be painful for somebody else and vice versa. But there is an objective part of pain, and that is physiologically those things that create pain are all the same. And it's really difficult to get people's head wrapped around the concept of, if I, stick your finger with a pin, the amount of objective pain that is created is the same for all of us. And somebody might sit there and stare at me as I poke them in the finger with a pin, and they go, "What? That's no big deal. I mean, what's the deal?" And some person, if I go to them with the pin, before I even stick their finger, they've passed out and thrown up on the floor. I mean, everybody is different. And so scientists have always been trying to figure out what is there that actually creates this pain signal. And this is what is new, and this is what is exciting, and this is what's fascinating. And you know that I'll share these things with you, but this is really, really cool. This study, reported in the journal Nature, was led by a doctor by the name of David Julius. He's a professor and chair of the Department of Physiology and Biochemistry and Physics at UCSF, University of California, San Francisco. The researchers were interested in the protein called TRPV1. It is found in specialized pain-sensing cells and is responsible for the cell's ability to respond to things like thermal heat, the spiciness of chili peppers with a thing called capsaicin, and other painful stimuli. The TRPV1 is an ion channel valve opener. Now let me break this down for you. Here's the thing. If you can imagine a cell, okay, and think of it like a balloon, and inside this is a balloon that's filled with water, and before you filled the balloon up with water, you put a nucleus in there, and you put little mitochondria in there, and they all float around inside this balloon, inside this water, and that is the cell. Now, the balloon part of the cell, there's an outside and an inside. And even though the wall is very, very, very thin, there is an outside and there's an inside. What they found is that this molecule, this is the molecule that mediates this opening, this channel, has a door on the outside and a door on the inside. And in order for you to get pain, both of these doors have to be opened. And it is the little cell that they were looking at, the TRPV1, that opens the little trap door on the outside, and it opens the little trap door on the inside, and this molecule travels through, and it creates an electronic charge inside the cell that then fires back off, and it creates pain. We've never seen this before, and these guys, here's what they did. They invented a microscope that is so good, and it sees things so small that they can actually see a single atom. No one has ever been able to do this before on anything, much less living cells. And they can actually go down and see a single atom in the size and detail that these are called 3.4 angstroms big. That is like a 10,000th of a hair. Okay, that's how small it is. But here's the important part. Why is pain important, and why is this molecule important? There are some conditions that we have called congenital insensitivity to pain, CIP. CIP, congenital insensitivity to pain, means you're born with it. You have an insensitivity to pain. And there's really two things that are at play here. One is an insensitivity. There are certain people that have a cluster of things called HSAN. It's called hereditary, sensory, and autonomic neuropathy. People that have HSAN have a variety of manifestations that they don't feel pain. And some people are insensitive, means that they don't feel pain. You poke them, this little valve that these scientists discovered, these little doors don't open. So there is no pain signal. The other is an indifference to pain. People feel pain, but they simply don't react. And we're not sure whether that's because they immediately release endorphins or something, but you hit them on their shin with a hammer. They feel pain. If you ask them, was that painful? They say yes, but they don't react. The other people, the insensitive people, simply don't feel pain. You hit them on the shin with a hammer and you say, did that hurt? And they'll go, no, I felt you do something, but it wasn't painful. It didn't hurt. It didn't make me go, ow, at all. It's absolutely fascinating. You're listening to the Dr. Randy Shoup Show, and I am your host, Dr. Randy Shoup. Now, why is this really, really important? It's important because these folks that can't feel pain, it is not a happy life for them. For example, let's say you pulled a muscle really badly while you were running or playing sports or did something, and you really damaged this muscle. Your body is sending pain signals to you that says, hey, knucklehead, you just weekend warriored and overexerted yourself and you tore up a muscle. You pulled a hamstring. You pulled your bicep muscle. Lay off of it so it can heal. Don't be an idiot and keep damaging it. These folks that don't feel pain don't get that signal. So they'll go out and, say, oh, okay, my leg's just fine. I'll go run 5 miles and just destroy their hamstring. Let's say you had a splinter in your finger that you didn't know about. It never hurt. It got infected. You got septic. It's bad news, but you don't know it. What about, have any of you ever scratched the cornea of your eye? I've done it numerous times, and I have no idea. I'm a klutz. I get it. But if you scratch the cornea of your eye, I'm telling you what, it is the most intense, gosh, awful pain on the planet. You run around with a patch on your eye. It's terrible. These folks, if they scratch the cornea of their eye, they just keep on going. If they have a grain of sand in their eye that is going up and down as they blink, scratching the dickens out of their eye, they don't pay any attention to it. So not feeling pain is not a cool thing. Unless you got, really like cool parlor tricks. But here's the important part. Now that we have seen these cells down to the atomic level, we know that molecule opens a little trap door on the outside and it opens a little trap door on the inside, and both of those trap doors have to be open in order for the chemical to go through and create pain. Guess what that does? It lets the scientists know what they need to do to block pain in you. So they can now redesign pain medications not to simply dull down your entire nervous system, not to simply just make you a zombie to where, you still feel pain, but you just don't care. They can actually create molecules, they can actually create medicines that will simply go to the cell and shut that door, either inside or outside the cell. And if they shut one of those doors, then you don't have pain. It's not like I don't have a little pain. It's I don't have any pain. If you can shut it out. Maybe if you cut yourself. Maybe if you break your leg. Maybe if you have a terrible, terrible bruise. Maybe if you sprain your wrist. Maybe if you've had surgery. What if they could simply slather on, just like on the old Star Trek episodes, maybe if Bones could come out with a jar of Vaseline-looking stuff, slather this on your arm, and all the pain goes away. That would be way cool. Significantly less invasive for you. You take less medication. That's where all this science is going. You're listening to the Dr. Randy Shoup Show. I am your host, Dr. Randy Shoup, and we're talking about pain. We're talking about where pain comes from, and we're talking about how scientists have just now developed microscopes that have allowed them to see exactly what it is that happens that creates pain in you and me. And because we know exactly what happens, now we can start to create medicines and molecules that will stop the pain process. Now, here's a couple of things that are really, really interesting. I told you there's this little gatekeeper on each side of the cell wall that opens or closes and guards the cell. Okay, there's this molecule that I told you about. You want to know a couple of interesting things? Spider venom goes to the cell, and on its own, the molecules, the compounds in spider venom, pry open the little doors without the little mediator guy being there, go through the channel and pop themselves into the pain cell and fire off pain. Spider bites are one of the most painful bites. Bee stings do the same thing. And mosquito bites, after they release histamine, do the same thing. They elicit pain. Apparently, these things want you to hurt. And that's why Mother Nature has designed all this chemistry to work together. So I thought that was pretty cool, that there are systems that go ahead and pry these doors open without the body mediating it. So if we could figure out a way to keep these things closed, your spider bite won't hurt as much. Your histamine response won't hurt as much. And so chemistry and biology and science are on the way to help you alleviate pain.
You're listening to the Dr. Shoup Show. Exclusive insider info, audio, and video is online now at ddsradio.com.